Hello, everyone. Your favorite disgraced science teacher, Izzy von Luismenverg here. Last time we went into space, we explored the planets of the solar system. But space is more than just planets. So, let's look at the other two notable objects that clutter the night sky. First up, let's start with the stars. Stars are massive spheres of plasma, primarily made of hydrogen and helium. They are incredibly hot objects, as even millions of miles away you can feel their heat. And basically anything that enters a star would be superheated so much they would be split apart at an atomic level. And they're so massive that they form their own sort of neighborhood. It's like a system, in a way. Stars are also the main provider of light, so without them we'd be in total darkness. Also, there would be no plants and we would freeze to death, but that's not important. Stars are born out of space dust. Some of this dust is left over from other stars that have died, and a lot of them form a construct known as a nebula. But regardless, the dust ends up getting squeezed together more and more, until eventually it becomes so heavy it collapses under its own weight, and basically undergoes nuclear fission. More and more material gets pulled in, and the object gets bigger and bigger, while meanwhile other materials around the newborn star will form into planets. Regardless of what happens next, everything around starts orbiting, and eventually the star is officially born. What happens next depends on how much material the star gathered in its infancy. Some become rather typical stars. From a distance, they look yellow, but they're really white. This is the kind of star our sun is. But some stars get so much material they become massive stars, which are blue. Sadly, though, nothing lasts forever, not even stars. Eventually, stars run out of material to burn, and they die. With how they go out depending on their size. Small stars like our sun will go out rather anticlimactically. Their outer layers gets blown off and become nebulas, leaving only the small white core. And I mean small. While our sun is larger than everything in our solar system, when it goes to white dwarf, it'll only be the size of our Earth. But eventually the dwarf will end up cooling off, and basically it'll disappear like a candle. Massive stars, however, have a different way of going out. They become so big that when they die, their core collapses under their own weight, triggering a massive explosion known as a supernova. What happens next depends on the size of the star. Some just leave behind their core, which is known as a neutron star. They're very small but super dense. But the more interesting thing that can happen is that sometimes a star becomes so dense that after it goes supernova, it creates an object so big, dense, and heavy that it has a gravitational pull that grabs everything around it. Nothing can escape, not even light. That's right, black holes. Anything sucked into a black hole will end up getting stretched incredibly thin in a process known as spaghettification, and no one knows what happens next. Since the dawn of time, stars have been observed by humans, and some notice that if you look at some stars, they seem to be in a position where you could theoretically see an image on it. These are known as constellations, and the most famous are the 12 zodiacs, which are visible during certain months. So that's stars for you. Now let's look at the planet's companions, moons. Moons are objects that orbit a planet. Most moons are the result of space debris getting caught in a planet's orbit without getting pulled in by its gravity. Mercury and Venus don't have moons, which is thought to be due to their closeness to the sun, so some people think any hypothetical moons would just get pulled in by sun's gravity. Earth has one moon, which, since it was the first one known, is just called the moon. It's a pretty big moon, especially compared to its planet, and it's the only surface outside of Earth that humans have walked on. The current theory for how our moon came into being is that when our Earth was being formed, a large object slammed into the side of it, and the debris ended up forming into the moon. The moon also famously has phases. You see, because the light given off by the moon is not its own, but rather reflected sunlight, this means that as it orbits the Earth, the sunlights get cut off at certain parts, leaving the moon in a seemingly different shape. Mars has two moons, Phobos and Deimos, named after the sons of Ares, the god of war, since the planet is named after his Roman equivalent. These moons are tiny. Phobos is only 14 miles long and Deimos is only 8. So yeah, not very big. These moons are also not very round. It's just by looking at them, it's obvious they used to be asteroids that got caught in the planet's orbit. Jupiter has a crap ton of moons. NASA calculates there are potentially over 90, and not all of them have been officially named. Jupiter was also the first non-Earth planet known to have moons. They were discovered by famed astrologist Galileo in 1610 when he found 4 of them, and those first 4 moons have been nicknamed the Galilean moons. At first, Jupiter's moons were named after people Zeus had relationships with in Greek mythology, but they ran out of people, so this theme was eventually dropped. The largest of Jupiter's moons is Ganymede, which is also the largest moon in our solar system. It's even bigger than Mercury. Then there's Europa, a moon that has fascinated scientists because its surface is covered in ice, which could potentially have oceans underneath, and if it does, there could even possibly be life. But unfortunately, we don't have the technology to get beneath the ice. We don't exactly attach drills to satellites, you know. Moving on to Saturn, they have the most known moons of the planets, of over 100. Most of Saturn's moons are named after other Titan or giant figures from mythology. The largest moon being Titan, fittingly enough. Titan is notable for the fact that it actually has an atmosphere, being the only known moon to have one. Plus, it has water, though it's full of ammonia. But because of these factors, it's another moon some people think could potentially have life on it. Uranus has 27 moons, and notably they're not named after anything related to the planet namer, but they're instead named after Shakespeare characters. The largest moon is Titania, but it doesn't have any sort of evidence for life, so it's boring. Next. Neptune is known to have 14 moons, named after water-related beings from Greek mythology, with the largest being Triton. And finally, Pluto has 5 moons, named after underworld figures, largest of which being Charon, which for a while was Pluto's only known moon until better satellite tracking let us know more. Charon is the largest moon in relation to its planet, being half the size of Pluto, and interestingly, the two almost seem to orbit each other. Because of this, some speculate they could be considered a binary planet. And I gotta say, seeing Charon at night, it's just beautiful. Pluto's such a lovely place to live on. You should really come by and visit sometime once light speed reaches the mainstream. And with that is the satellites of our solar system. Space is such a wonderful place, isn't it? I miss Earth sometimes, but honestly, being all the way out here, it does kind of ease the nerves a bit.